So hey guys, welcome back to the channel. This is your physics buddy. In the recent classes, we started AP Physics 2 curriculum and we were talking about electricity and magnetism unit. We have covered different units already on this channel. You can check those videos out as well. This is going to the last lecture of this unit in which we'll be talking about Gauss Law and we'll be referring the book given by your college physics. Apart from this, these different units from this AP Physics 2 curriculum has already been uploaded on the channel. Do check them out and do refer to those videos for your quick learning as well as understanding that what kind of questions are being asked in the final exams. Whenever we have something new, learning, it requires time, it requires patience, it requires hard work. So just stick to the video, make sure you subscribe to the channel and let's get started.
Quantities. It all started with charge. After charge, we talked about the force that exists between the two charges, and that force is known as Coulomb's force. And this force told that whatever force one charged particle will be exerting on the other, the same amount of force will be experienced by that charged particle also. The forces are equal but opposite in direction. Then, after studying force, we understood, or you can say, unlocked a new concept called electric field. The most important formulas that we need to understand here for charge, it was Q is equals to NE, or you can say the quantization principle. Whereas when we're talking about force, force actually deals with Fe, which is equals to KQ1 Q2 by R square, where R is supposed to be the distance between the two charges. Then it comes the electric field. An electric field is defined as force per unit charge. That force is electrostatic force. So it comes out to be KQ1 over R square. So these were the three main formulas we studied. Then we saw one application part as well. In the application part, we talked about dipole and we tried to find out electric field due to dipole at various positions. So the first position we discovered here is axial point. So at axial point, when we found electric field at axial point due to dipole is equals to 2kp by r cube. This is again another important relation that we need to keep in our mind. Similarly, when we talked about equatorial point, the field reduces to half. It becomes kp by r cube. From here only, we got a relation that axial electric field is equals to twice of equatorial electric field. So this is the relation between these two physical quantities, these two electric fields for the dipole. Then at last we talked about torque acting on electric dipole. So torque is came out to be P cross E, where it can be written as P is sine theta as well, where sine theta is supposed to be the angle between the dipole and the electric field. So far from our last few classes, we have understood these particular terms as well as we talked about the numerical section as well. We discussed so many problems based upon these particular formulas or you can say relations. In today's class, we are going to understand a very important topic which is supposed to be called Gauss law. So what this Gauss law is and how it all works, we need to understand a few properties about conductors once again, or we just need to look at those properties which we already discovered about conductors. So for conductors, they have free electrons which are the reason for conduction. If a conductor doesn't have any electrons or you can say the free electrons, it won't be able to conduct. And that's what makes insulators. No free electrons. Electrons are bounded in such a way that they cannot move and at any form of energy given to it. So what we need to understand here is that suppose if this is a conductor, this is a random shaped conductor, and we just try to understand that how charges are spread across the conductor. So charges are never spread across the conductor inside the conductor. They are present on the surfaces only. Like if we have to actually pass electricity through it, what we are supposed to do? We're supposed to connect the conductors, and through its surface, as there are free electrons present, the current is supposed to flow. But inside there is no charge. So if inside there is no charge, we can say electric field inside the conductor is supposed to be zero. Whereas For the conductor only, electric field outside will be like that, a straight line coming out of it. This is because of the conductors which are spread across the surface of the conductor. So here we got to know, and this is a very important property about conductor, that conductor doesn't store charge, any of its charge inside, you can say, configuration. The charge always lies on the surface. That is the most important part about conductor that we have to understand. Here, all charge lies on the surface of conductor. No charge inside it. Q inside 0, electric field inside automatically becomes 0. Why? Because electric field is what? KQ by R square. So if Q himself become 0, so electric field will automatically become 0. There is no doubt in that. Now let's try to understand a new thing, which is known as uh, electric flux. Electric flux is that quantity used in physics which actually represents how many number of electric field lines are passing through a given area. Like for example, quantity to identify number of field lines passing through area, through unit area to be precise. Like for example, suppose this is the electric field lines I have. One is like that, other is like that. Now what we do is we just assume two similar areas. One is this A1, another is this A2. Now just think and tell me which surface area allows more number of electric field lines to pass through it. Tell me.
A2.
Exactly. So A2 will allow more electric field lines to pass through it. So now you have to just understand this fact that the flux of A2 will be greater than flux of A1. That's all. This is all what you need to understand about electric flux. But how many number of electric field lines are passing through a given unit area? That's it. This is what you have to understand about flux. Now, what Gauss law says, because that was the topic. So Gauss law says that electric flux passing through a Gaussian surface is 1 by epsilon naught times the charge enclosed by the surface. So this is what you have to understand, that what this thing is. So we understand electric flux. Now, suppose there are two spheres. I'm assuming two spheres. They are hollow spheres, even three. Now these three spheres carry some charge, and I'm assuming it carries charge Q. It is carrying charge 2Q. It is carrying charge 3Q. Now just think and tell me, when these charged particles emit electric field lines, which surface experience more number of electric field lines passing through it? A, B, or C?
C.
Exactly. So here we can say flux for C will be greater than flux for B will be greater than flux for A. So what this Gauss theorem says is that flux is equals to charge enclosed over epsilon naught. This is what Gauss law is. We simply observe this fact that if the charge enclosed is more, flux will be more. And this is what we found here from the flux definition itself. But based upon his studies and all, his experimentation and everything he did, he found that flux is directly proportional to, we can say flux is somewhat charge over epsilon naught. That is permittivity of free space. So this is the factor that actually reduces flux, permittivity of free space. Or we don't know whether it increases also. But if the medium changes, flux will automatically change. That is also we have to understand because permittivity is a medium, you can say, factor, medium depending factor. So this was all about electric flux, and through this particular fact only, that this is the last part of the chapter, we are done with this particular chapter. So before actually starting the new chapter, there are some questions that we actually discussed from the book itself. So as far as I checked the book, there were very few questions based on Gauss theorem, so it's not an issue. What's important here is that there are few questions, so we don't have to think much about it. We can go with our own understanding. If we didn't get it properly, it's completely fine because this is not something which is very important. But still, it's a part of our syllabus, so we have to do it. The Gauss law for electric field are qualitative approach. Qualitative approach means where you are not actually solving problems, but you are actually discovering the concept. So suppose the question says, suppose a Gaussian surface encloses both positive and negative charge that has 6 field lines leaving it and negative point charge with twice the magnitude of charge of positive one. What is the net number of electric field lines passing through the Gaussian surface? Now just think naturally. Suppose this is my surface and it contains equal amount of charges, not equal amount, but it contains two charges, one is positive, one is negative, but the positive one is half of the negative one in terms of magnitude. So I can assume positive is q and negative is negative 2q. The question says that positive charge releases 6 field lines. So if it is releasing 6 field lines, 2q charge must be capable of releasing 12 field lines. So if from positive charge 6 field lines are going into negative charge, then remaining 6 of this negative charge will definitely be coming out of it. So if remaining 6 will be coming out of it, so there must be some number of net field lines passing through the Gaussian surface, and that number is what? 6. That is what we have to understand here. Qualitative approach more than what analytic we have to find like in other problems. Just try to think in such a way that you are able to solve some conceptual questions as well, which are quite easy, not that much difficult. Next question, let's try to do it. A Gaussian surface has 16 field lines leaving it when it is surrounded by a point charge of 10 microcoulombs and 75 field lines entering it when it is surrounded by unknown point charge. Now that's an interesting question. We have to do a little bit of solving here, but that's completely good to go with this particular problem. So question says, once again, 16 field lines leaving it. So if a Gaussian surface is leaving some field lines, it must be positive in nature. So there are total 16 field lines, we can assume it is leaving it. When it is 10 coulombs charge only, inside it is 10 coulombs. So 10 coulombs is directly proportional to 16 field lines. This is the proportionality we got here. Question says, if it is surrounded by 75, when it was 16, only 10 charge coulombs, 10 microcoulomb charge was there. So when it is 75, what amount of charge would be there? Let's just do the simple maths. So I can say x over 10 must be equals to 75 over 16. So x is going to be 750 over 16. So tell me the value of charge. What's the value of x?
2 770 divided by 16, 46.8.
So almost 47 number of field lines must be exiting. No, sorry, entering. So it must be negative of 47 microcoulomb charge. That should be the answer. That's it. You just have to figure it out that what exactly is going on, and you can simply just do the basic maths. This is only applicable on the questions which are qualitative in solving. Question says the magnitude of the unknown charge is greater than 10 microcoulombs, equals to 10 microcoulombs, less than 10 microcoulombs. Why? What is the unknown charge? So it is greater than 10 microcoulombs, or we can say it should be less than 10 microcoulombs because it is negative. So C option would be correct. And why? By just looking at this particular fact that 10 microcoulomb charge is responsible for 16 field lines in the surface. So that is the way of doing it. Did you understand it?
Yes, sir.
The next question we have to discuss here is, if it says if 10 field lines leave a Gaussian surface when it is completely surrounded by positive end of an electric dipole, what would be the count if the surface surrounded just the other end? What if it is surrounded both end? Now the question is, suppose this was the dipole charge and Gaussian surface is like that. So if it is surrounded by like that, electric field line must be going this way. The question is, what was the behavior of electric field line? What is it surrounded with both ends? What will happen? So the whatever number of electric field lines are coming out of it because of this positive charge, the same number of electric field line will be entering through the other Gaussian surface that would be of same charge. So the 10 electric field lines must be entering into it. Like, are you getting it? It's so simple. The question says
Yeah.
if it's a dipole carrying positive and negative charge. So whatever number of field lines will be coming out of that positive charge, that same number of field lines will be entering into the negative charge. So if we just assume that there is a Gaussian surface at this end and the same Gaussian surface is present at this end. So what would we say? We will say that the same number of electric field lines which are exiting from the first Gaussian surface must be entering into the second Gaussian surface. That is what qualitative approach is. You just have to figure it out that how things are going on. Some more questions are there. Let's do them. On average, the electron, proton, and hydrogen atom are separated by a distance 5.3 times 10 to the power minus 15 meters. Assuming the orbit of the electron to be circular, what is the electric force on the electron? Now, it's a simple question. Just requires some maths to solve it. So it is electron and proton in hydrogen atom. So electron and proton have same charge. So the force that is going to act is going to be KQ1 Q2 over R square. This is going to be the force, electric force, which we have to find in the first part. So you can find it out. What is the charge of electron? 1.6 into 10 to the power minus 19. What is charge of proton? Same charge. That's it. Assuming the orbit of the electron to be circular, so R is going to be this 5.3 into 10 to the power minus 11. So that is the first part. You can easily do it. I think I should move to the second part. What is the electron orbital speed? The question is, with what speed electron was actually orbiting? So here you can see electron must have some velocity v. So it is there because there is one force that is acting inside, which is supposed to be Fe, but simultaneously there is another force which is acting outward, which is called centripetal force. The centripetal force mv square by r is equals to kq1 q2 by r square. When you solve this equation, as you must have found the force in the very first part, and mass of electron is again, we know, it is 9.31 into 10 to the power minus 31 kg. Not 31, 9.1, that's it. Into 10 to the power minus 31. R is again the same, 5.3 times 10 to the power minus 11 meters. So again, here you have to understand these questions are not something which you can directly solve without understanding the concept. If you are able to understand the concept, then you can solve it. What concept is needed here to understand or to solve this problem? To understand this fact, whenever a particle revolves in a circular orbit around anything, there must be two forces. One force must be acting towards the center, another force must be acting outward, or you can say away from the center. And these forces should be acting in such a way that they cancel out each other. Because if they are going to cancel out each other, then only object is going to oscillate or revolve around that part. Otherwise, it won't be able to. So there must be two forces acting at the same time if it is, we can say, circular motion. So you can just substitute all the values and get the value of velocity also from here. So this was a part, this was a B part, and I hope you can do it now. And it's important, you should do it. The third part says, what is the magnitude of electron centripetal acceleration in units of g? This is an interesting one. So acceleration, that is centripetal acceleration, it is always equals to v square by r. So whatever velocity you'll find from here, just substitute the value of v and divide the same thing by r. You'll get the velocity acceleration of centripetal. And in case it's saying it's unit of g, so what you have to do in order to find it in units of g, you have to divide the whole number by 9.8. So the unit is going to be g in this case for acceleration. And again, this is centripetal acceleration. This is the thing which we understand actually in circular motion. You must have understood about circular motion in 2 dimensions. So that is the thing, that is the case you need to keep in mind to solve such problems. Again, this is your homework. Make sure you do it as a part of the revision. If you are able to do these things, the chapter is done from your end as well. and we don't have to make it like that. We'll do it later on. We can do it now. We'll do it now. That's it. Next question. So now this is an interesting one. Question says a negatively charged pith ball is suspended vertically from a light non-conducting string of length 15.5 centimeters. So there is a charged pith ball which is having this mass and this charge. Let us do this question sideways. First of all, let's draw the figure so that we'll be able to solve it somewhere else as well. So this is the pith ball. It is having some mass. It is having some charge. It is supposed to be negative of 1.5 nanocoulombs. This apparatus is then placed in a horizontal uniform electric field. So now there is electric field. Great. So if there is electric field must be horizontal, that it is suggested by the question. So now this is something which the mass will experience, electric field. Now the question says, after being released, the pith ball comes to a stable position at angle of 12.3 to the left of the vertical. 12.3 to the left of the vertical. This means now object will be here and this angle should be 12.3. Leftwards, it's already mentioned leftwards. What is the direction of external field? This is what we have to understand. Determine the magnitude of electric field, and we also have to find out field. Now, how to do such questions? That is a very important and critical part. Let's try to solve this problem. Although it's important to keep the data in mind, and it is very important to keep that also. The question says that there was a pith ball which was just hanged like that. This pith ball has charge of negative 1.5 nanocoulombs. And what happens here is that a strange electric field came into the picture like that. Like we don't know the direction, we're just assuming that it should be like that. So this is what we have to find direction. We don't know the direction also, we'll try to figure it out that what is the direction of field line. So the question says later on what happens here is that this pith ball which is suspended from the length came at this angle which is supposed to be 12.3 degrees, and keeping this point in mind that initially it was charged negative 1.5 nanocoulombs. So just try to think and let me know if the negative charge is going this way, what is the probability of having charge in this particular region, and what is the probability of having charge in this particular region? Negative charge is going this way towards left. So what is the probability of charge? Like what is the nature of the charge that should be placed at this particular left side? What do you think? What it should be?
Positive.
Exactly, positive. And here it should be negative because it is going away from negative charge. So what is the field line? Like how we actually look at field lines? Field line always enter, or you can say leave positive charge and always enter the negative side. So the field lines must be like that. This is the direction of electric field line. This is what we understood here from this particular, we can say, given information. So one thing is quite clear now. Electric field here is acting. It is going to be around. It is going to act from left to right direction. So one part is done. Now just tell me what is the mass of the ball. What is the question number exactly? It is.
Huh?
What is the mass of the pith ball? What is the question number of the question?
I'm not understanding what you're saying.
I am saying, what is the mass of that pith ball? Just look at the question and tell me the mass.
Okay. Negative 1.5
Mass cannot be negative
nanonewtons.
1.5.
1.5 nanocoulombs.
Mass cannot be negative. Look at the
Okay.
question again and tell me. 6 into 10 to the power minus 3 grams. 15.5, 12.3.
Okay.
These are the given things. So mass was supposed to be 6 into 10 to the power minus 3 grams. And is it grams or kg?
Grams.
And it is 15.5 centimeters. And the angle is 12.3 degrees that we already found. Now let us try to understand how and what exactly is going to happen here. In order to see the forces, or in order to find out the electric field, we need to understand this thing. That in order to solve this problem, we have to draw the FBD. This was my angle 12.3 degrees. This is supposed to be my mass. So if it is going this way, that is, it is going towards left, so it must be experiencing force towards left. So the electrostatic field must be acting this way. Electric field must be acting this way. And there must be some weight of the ball as well, which might act in the downward direction. And because of this weight and this force, the string will automatically develop a tension. And that tension is supposed to be represented by T. But the interesting part here is we have the angle. So with the help of angle, we can form equation. If this is 12.3, this is also going to be 12.3 degrees. Now again, what you need to do is you need to resolve the forces. And how we are supposed to resolve the forces? This T will be distributed into x and y axis as T cos 12.3 degree, whereas here it should be T sine 12.3 degrees. Now what we can write in place of force? As we know, electric field is nothing but force per unit area, force per unit charge. So force must be electric field times charge. So in place of this, you can write EQ. Now we'll resolve the forces in x and y axis, both sides, both axes. Let's see how can we do this. So we'll simply say resolving forces in x axis and y axis respectively. So see what the equation we are going to get. E electric field times Q is going to be T sine 12.3, whereas weight is supposed to be T cos 12.3. What we can do here is we can just simply divide these two equations. If we divide these two equations, see what we are supposed to get. T sine 12.3 divided by T cos 12.3. We will cancel out T. We have to find electric field. Electric field is going to be tan 12.3 into mg divided by q. So now we got the relation which actually going to give us electric field. Now we substitute all the values of the given information and we get the value. So just tell me what is the value of tan 12.3. What is the value of tan 12.3?
0.02.
0.02.
It's 0.02.
So once you solve this equation, you'll get the value of electric field. This is what you have to find here. I hope you understand this question.
Yes,
Because if
sir.
you are able to solve few questions like this, the chapter is under control. You can easily solve any problem.